Every morning, 2 billion cups of coffee are brewed across the planet. The grounds get scraped out, dropped in a trash can, and forgotten. What follows is one of the most quietly damning stories in modern industry. Those grounds travel to landfills where, crushed in without oxygen, they rot and release methane, a greenhouse gas more than 25 times more potent than carbon dioxide. Meanwhile, the construction industry is running out of sand. Not slowly, urgently, irreversibly. The United Nations has confirmed that demand for sand has tripled in the past 2 decades. 50 billion tons consumed every year, far faster than rivers and ocean floors can replenish it. Entire islands in Southeast Asia have been dredged out of existence to feed concrete plants. Here's what nobody in that industry wants you to know. The problem and the solution are sitting in the same trash can. A team of engineers at RMIT University in Melbourne proved that used coffee grounds, processed with nothing but heat, produce a material that makes concrete 30% stronger. You cannot buy this at a hardware store. Not because it does not work, because of who profits from what you use instead. Stay until the end. The sand crisis is not coming. It is already here. The United Nations Environment Program has confirmed that humanity is consuming 50 billion tons of sand and gravel every year, a rate so far beyond natural replenishment that the gap is no longer measurable in years. It is measurable in generations. Rivers that took centuries to build their beds are stripped in a single dredging season. Coastal ecosystems dismantled block by block to feed the next concrete pour. In Indonesia, more than 24 small islands have disappeared entirely since 1990. Not flooded, excavated, removed from the map to supply construction markets in Singapore and Malaysia. The concrete industry is the second largest consumer of natural resources on Earth after water. And the raw material at the center of that consumption is not renewable on any human timescale. A riverbed takes centuries to rebuild what one extraction operation removes in a week. The industry's response to that fact has been consistent and simple. Dig faster, go deeper, move to more remote sites. No major construction standard anywhere in the world has mandated a reduction in sand use. The material holding up every building on your street is running out, and the industry selling it has no interest in telling you what could replace it. The study was published in the Journal of Cleaner Production. Peer-reviewed. Not a press release, not a startup pitch, not a sponsored white paper. A formally reviewed scientific finding with methodology, controls, and data that other researchers could replicate and challenge. The finding was this: used coffee grounds, heated to 350 degrees Celsius in a low-oxygen environment, are converted into a material that makes concrete 29.3% stronger than the standard mix holding up your house right now. The process is called pyrolysis. It is not new science. The word comes from Greek, pyr for fire, lysis for separation. Ancient Amazonian civilizations were running a version of the same process more than 2,500 years ago. They worked the resulting carbon into soil and created what researchers now call terra preta, black earth. Patches of that soil still exist in the Amazon basin today. Still fertile, still outperforming every surrounding plot of ground. Centuries after the civilization that built it collapsed. What those ancient cultures understood, and what the RMIT engineers rediscovered, is the same principle. Heat organic waste without oxygen, and you get a porous, carbon-rich material with structural properties modern chemistry is only beginning to fully map. The RMIT team did not stop at the laboratory. They ran a field trial, real road construction, coffee biochar poured into actual concrete at an actual project site in Australia. The data held under real infrastructure conditions. That study has been cited in engineering press, covered briefly in news cycles, and then quietly allowed to fade. The global concrete market was valued at $1.82 trillion in 2024. Every ton of sand replaced by a waste product is a ton that the supply chain did not sell. That is not a marginal concern. That is an existential threat to a revenue model built entirely on sand being irreplaceable. Understanding why this works is what separates you from the person who hears about it and dismisses it as fringe. Standard concrete does not fail randomly. It fails at specific points, and those points are predictable. Sand particles are dense and smooth. When moisture penetrates the concrete matrix, it undermines the bond between those smooth particles and the cement paste surrounding them. That is where cracking begins. That is where structural integrity starts its slow collapse. Coffee biochar changes this dynamic at the molecular level. Its surface is not smooth. It is porous, riddled with microscopic channels carved out during the pyrolysis process. When that biochar is mixed into concrete and the cement begins to hydrate, two things happen simultaneously. The porous surface bonds more aggressively with the cement matrix than any polished sand particle can, and those microscopic channels act as a reservoir, holding moisture and releasing it gradually as the cement cures from the inside out. Engineers call this internal curing. It strengthens the cement matrix during the most critical phase of its formation, the period when it is setting and most vulnerable to shrinkage and cracking. The result is a denser, harder, more cohesive structure than conventional concrete achieves under identical conditions. And concrete is not the only material that responds this way. In separate research, scientists mixed coffee grounds into fired clay before kiln firing at 950 degrees Celsius. The grounds burned away completely during firing, leaving behind a closed cell porous structure inside the brick. The result was lower density, better thermal insulation, and structural resistance fully suitable for load-bearing construction. 3 to 5% coffee grounds by weight produce the optimal balance. Two completely different building materials, two completely different applications, both measurably improved by the same waste product currently sitting in your trash. This is the part that should make you feel something, because the method is not exotic. It does not require a factory, a permit, an engineering degree, or a supply chain. It requires a metal container, a heat source, and spent coffee grounds. Start with the grounds themselves. Moisture is the enemy of clean pyrolysis, so the first step is drying. Spread your spent grounds on a baking tray and place them in a conventional oven at the lowest available temperature for several hours until they crumble completely at the touch. Then comes the conversion. Seal those dried grounds inside a lidded metal container. A cast iron Dutch oven with a foil-sealed lid works. A sealed stainless steel canister works. Take it outside. A fire pit or a propane burner, not an indoor kitchen. Apply sustained, even heat for 60 to 90 minutes. You are not trying to burn the grounds. You are driving a controlled thermal breakdown without combustion. You will know the process is working when gases begin venting from small gaps in the seal. Those are the volatile organic compounds escaping. What remains inside is biochar. Porous, carbon black, chemically transformed. Let the container cool completely before opening. Crush the result to a consistent granule size. Then mix it into your concrete at 15 parts biochar to every 85 parts sand by volume. Standard Portland cement, aggregate, and water ratios stay unchanged. The concrete you pour from that mix is structurally superior to anything your contractor will deliver using conventional materials. The research is not hidden. It is published in open access journals, covered in engineering press, and available to any building standards committee that chooses to look. Nobody is suppressing the study. What is happening is quieter than suppression and more effective. The pathway from published research to standard construction practice runs directly through industry standards bodies, material certification processes, and professional procurement chains. Every one of those checkpoints is staffed by people whose careers and companies are built on selling the current version of concrete. The resistance does not announce itself. It operates through inertia, through procurement departments that buy what they have always bought, through certification timelines that stretch years before a new material can be specified on a commercial project, through supply chains optimized entirely for sand, with no existing infrastructure to route spent grounds from coffee shops to processing facilities to concrete plants. That infrastructure does not exist at scale because no one currently in the supply chain profits from building it. A peer-reviewed field trial proving 30% strength improvement has not changed a single mainstream construction product specification. Not one. The global concrete market will reach $2.2 trillion by 2030. Every ton of biochar that replaces sand is a ton. Those contracts did not move. The physics does not care about industry timelines. And neither do you standing in your backyard with a sealed pot and a bag of used grounds. Pre-Columbian Amazonian peoples built soils from organic waste and heat that outlasted their civilization by 2,000 years. No patent, no supply chain, no permit office. The coffee grounds in your filter this morning contain that same chemistry. The process is not beyond what a backyard fire in a sealed pot can achieve. The research is published. The field trial exists. The data held under real infrastructure conditions. A material you throw away every morning has been proven to outperform what a trillion-dollar industry sells you as the only option. The only thing standing between you and that knowledge is the speed at which an industry built on sand is willing to move.